In this video, I'm going to follow a step-by-step procedure to make a simple plat based upon field information. We'll start by launching Carlson through the icon on the desktop. At the Startup Wizard, I will hit New to create a new drawing. I am going to use a template drawing. It is a good idea to set up a template. Just any simple template having units set for your normal working practice and layers, so you're not constantly creating layers as you go along. I am going to select the template supplied with Carlson called carlson.dwt. At the Drawing Wizard, I hit New to create a new drawing, and I'm going to entitle this drawing Plat. 20 scale drawing will be fine. I am not on a projection. This is an assumed coordinate system. The program automatically creates a coordinate file with the same name as the drawing. It can be changed if you like. I'm going to leave it that name, and I am going to go ahead and import points from a text ASCII file at this time. I will select the text ASCII file, plat.txt. You can see in the preview there are 50 points in this file. The format is correct. I didn't have to change anything here. I am not going to draw the points at this time, but I am going to store them to the current coordinate file. And I hit OK. It imports 54 points and asks again if I would like to go ahead and draw those points. We can quickly look at that data. Through Edit Points, you can see a variety of field data, manholes, edge of pavement, some trees, shed, building, utility poles, etc. The reason why I did not draw all the points right now is because they were all going to come on a single layer, and what I'd like to do is control this drawing technique just a little bit. So what I'd like to do is take a look at my data first. What I'm going to do is list points, and I'm going to turn on the Use Report Formatter. What I'm going to do is put the description in first, so it sorts by description, and then just the point number. The report formatter gives me a lot more latitude and control of how I want to display my information. After I've selected my fields, description, and point number, I'm going to sort this by description by putting description on up and point number on down, which is going to set those orders in that direction. And when I hit display, I have a nice sorted data set that I can print out and see just the different types of descriptions. Once I've printed my data, I'm just going to exit this routine and move on to the next step. To aid in drafting, what I'm going to do is put my data into point groups through the Point Group Manager. I execute that routine, and I begin by creating a point group. The first group I'm going to create is one for the boundary of the property. In this instance, I know the point range, so I'm going to turn off Include All, turn on a point list, and I know that points 1, 8 through 10 and point 15 are all part of the boundary. My next group is going to be trees. Instead of using point numbers in this case, I'm going to use descriptions and select them from the coordinate list. When I find descriptions that are suitable for trees, I just highlight it, hold the Control key on the keyboard, and select the ones that I want to include as trees. Now we're adding the description. Since these two are duplicates, I don't need to select them both. When I hit OK, you will see each description separated by a comma. I'm going to create another group called Buildings. I am also going to select those by description from the list. I see a BLD and a shed. When I look at the buildings, I have all the points with the description shed or BLD. I will continue along this method, and I will call the next one travelways. I had description edge of pavement, and PV for pavement. Now you noticed that some of these have designations as a PC for point of curve, PT in some instances as well. So after I select that, I'm going to add an asterisk at the end of EP at the end of PV, which is a wildcard, so it will tell the routine to take any part of the description that comes after EP or PV. The travelways layer now has all the points. I'm going to create another group called utilities. This is going to include manhole, there's a light pole, and a utility pole. Another group, hubs, which are the description hub. And finally, we have just spot shots, and they are using the description X. By highlighting all of the groups at once, holding the Shift button on the keyboard, you can see in the display window to confirm that all the points consecutively 1 through 54 are included in our point groups. I can now control the way I bring the points in. I could go to Draw Locate Points, and let's start with the boundary. I'm going to start with the layer points-BNDRY. For a symbol, I'm going to pick something that simulates an iron pipe. And instead of drawing all, I will draw by point group, select my boundary point group, and hit OK. These points are brought in with the symbol on the layer, points-boundary. I'm now going to draw the boundary line for this particular parcel. So I'm going to start by using my layer manager, typing LA on the command line prompt, or the layer control button on the layer toolbar, and create a new layer by right-clicking in the screen and selecting New Layer, and I'm going to call this BNDRY and give it a color green. Set this to current by double-clicking on it and closing out the layer manager. To draw the boundary line, I'm going to use a polyline. Under the Draw menu or the Draft ribbon, select 2D Polyline. Note the option to use current drawing properties, which allows you to create the layers on the fly. This command is quite versatile. We're going to begin by simply typing in point number 1. Note the prompts at the bottom of the screen. You can enter arcs, you can enter in distances and followed by angles. You can follow or in a sense trace an existing polyline. I can simply type in another point number or a range of point numbers. So I'm going to type in 8 through 10, which draws the points now connecting 1 through 10 are all connected. I'm going to hit enter to get out of that command and then execute that command again to demonstrate another option. When there's an existing polyline, I have the option to continue. If I hit C for continue, I can pick the end of the polyline where I would like to begin continuing from, and you will see following my cursor is a continuation of that polyline. I still have the option now to type A for an arc. Notice that the arc begins tangent to the previous line. With that in mind, I can simply type the point number 15, which is the end of the arc. It created an arc tangent to the line coming in between 9 and 10, to point 15. To close out the boundary, I will just re-enter point number 1, the point of beginning. Note that the program displays the total length of the perimeter of the polyline entered in, along with the point number data. By hitting F2 on your keyboard, you can actually see the coordinates, point descriptions, and information for each segment of that polyline. To continue drawing line work using the 2D polyline command, I'm going to first create a new layer for the boundary right-of-way lines. I do that by highlighting the boundary and hitting New Layer. You'll notice that when you do that, it creates a new layer with the same attributes as the layer that you had highlighted. So I'm going to call this BNDRY-ROW. I'm going to change that layer color to yellow and set it current. I'm once again going to execute the 2D polyline command from the ribbon. Now what I would like to do is draw right-of-way lines that continue along the same bearing as the property lines that you see already drawn. So I'm going to begin by just picking the endpoint of the line to start with. I am going to draw a line 100 feet long on that same bearing. To do so, I first type in distance and enter the distance of 100 feet. Now, as you're entering this, note the prompts on the command line. You can enter meters, feet, chains, lengths, or pick, which simply means you would pick a distance. I'm going to type in the distance. The default is in feet, as you can see in brackets, of 100 feet. The next prompt asks me how I would like to determine the angle of this line. You can use your cursor, which means it will follow wherever your cursor is pointing to. You can select a previously drawn line for a bearing recall, or the option pick means you would just pick a direction on the screen. Angle would allow you to type in a bearing. By hitting A, you will see Carlson works in terms of quadrants. Your options are a quadrant 1 for northeast, 2 for southeast, 3 for southwest, 4 for northwest, 5 is an azimuth, 6 is an angle left, 7 is angle right, and 8 and 9 are deflection left and right, respectively. Since I already have a line drawn in the CAD file and I would like to duplicate that line, I can do that bearing recall of that line. So I backed out of that command as far as the angle entry part of it was concerned, and I will, instead of hitting A for angle, I can pick L for line. And then I just simply pick that line segment, and you can see that it drew a polyline at that bearing at the previously entered distance of 100 feet. And now hit Q to quit that part of the command. To demonstrate another command for drawing geometry, I would like to draw an arc from the beginning of this point tangent to the line coming in this direction, turning to the right. To do that, I'm going to use the command under the Draw menu, Arc, and Curve Calc. In the ribbon, that is found in the Draft ribbon under the General Draw tab, and Curve Calc at the bottom. When I execute that command, I get a separate dialog box. What's convenient about this command is that you can put in any of pieces of information about the curve, and this will calculate the remaining elements of the curve. For example, this is a 300-foot radius, and the arc length is 100 feet. The command calculates the rest of the information of the curve, so if you're reading that off of a plan, you have checks. You can enter it in as a roadway or railroad type curve. When you're satisfied with the information, hit plot. The command will prompt you to start the PC, the beginning part of the curve, which is this endpoint. Then you have two options: to plot tangent from the line coming in, or manually type in the direction of the coordinate. I will pick T for tangent, and the command prompts you to pick any point along the tangent line coming into the curve. It's snapping to nearest. Once I pick a point on the tangent line coming in, it temporarily draws an arc and asks if it is drawn in the correct direction. In this case, the curve is being drawn to the left. I would actually like it to the right, so I simply hit No, and it redraws it to the right, and I can exit out of this command. We can now start paying attention to the other data in this survey, but before I continue, I'm going to reset my drawing orientation so it's a little bit more perpendicular to the screen. Right now, north is straight up, but I would like to rotate this property line just a little bit. I'm obviously not going to rotate it using an AutoCAD rotate, which would alter the coordinates. I am instead going to go into the draft menu, and under general view I'm going to pick line, polyline, or text. Now this is a twist screen command that reorients the drawing cosmetically only. I'm just going to pick this upper line that's drawn as part of the boundary and hit enter, and it reorients the drawing. And if you'll notice, the north now has a bit of an angle to it. This command does not alter the coordinates whatsoever. So I'm now going to start drawing more detailed information. To do so, I'm going to go back into the points menu and hit draw locate points. I'm going to use point groups for this part of the operation. So to recall, we had a group of trees. So I'm going to start by drawing in the trees. I'm going to put them on a layer called trees and select the symbol from the tree category. And I'm just going to go ahead and have all my trees use a single symbol. I'm going to draw by point group, select the trees point group, and hit OK. By examining my drawing, you'll see that I didn't really have the scale set properly. My trees are quite a bit too small. So I'm going to rescale those. To do so, I'm going to use the resize point attribute command under the points menu. Again, these are duplicate commands. They're under the points drop-down, resize point attributes. The method for resizing is a scale or absolute. I'm going to pick scale and make them 5 times bigger than they are now. My options are to scale the symbols, labels, or both. I'm just going to scale the symbol because the tree symbols are the only things that are too small. I don't want to resize my attributes. I'm going to pick them by a point group. Notice the group option screen or number. Again, select the tree group, hit OK, and the trees are now resized. Now we're going to address drawing the line work for the building and shed locations. Before I do that, I'm going to go back into my layer manager and set to the layer called existing. The point group manager has an option to draw line work as well as points. To use that option, we go back into point group manager, highlight the category buildings, and on the right, holding the shift key, highlight the 3 shed locations. Under points, hit draw 2D line, and it draws the line work for the shed. I'm going to repeat that for the building. Point group, buildings, the 2 BLD shots, points, and draw 2D line. To complete this line work, I'm first going to address the shed, and you can see 2 sides of the rectangle are drawn. There is a command in the survey pull-down called 4-sided building. This command works with either 1 or 2 parts of the building drawn. Since 2 sides of the building are already drawn, I just simply pick that polyline and it completes the rest of the rectangle. To draw the house indicated by the 2 building shots, which is not a simple rectangle, it has many jogs to it, we're going to use a different draw command. This is actually under the edit menu, and it is extend by distance. The location of that command on the ribbons is under the draft menu, extend by distance. I'm going to pick the part of the line that is already drawn nearest point 18. You'll see this arrow that shows the direction the line is going. From that direction, we can use all the options you see in the brackets below. To see those options displayed on the screen, type H for help, and you will see what you are capable of doing with this one simple command. We are going to be taking advantage of L and R for left and right rotate. To use that, so we're going in this direction. If I type L10, it will add a link to the polyline left at 90 degrees, 10 feet. I will continue along with that, entering the dimensions of the building. And C to close the figure. Next, let's take a look at our point group travelways. In here we have PV, which are pavement edges of a driveway, and EP, which are pavement edges of the street line. These points also need to be used to create a surface model. So what we actually want out of these are three-dimensional break lines, which Carlson will use as a break line in creating a surface model. So I'm going to start by inserting all those points into the drawing. Now that the points are in the drawing, we need to connect those with three-dimensional polylines. To do that, I'm going to use a tool under the Draw menu, under the Polyline flyout, called Polyline by Nearest Found. I'm going to set that to a 3D polyline. The maximum separation to join would prohibit the program from connecting points that are farther than 100 feet apart from each other. I happen to know that we have some pavement shots that are much farther apart from that, so I'm going to increase that to 400. I would like to only connect the points called EP. So I enter in EP with an asterisk at the end, so it will take in any descriptions that follow the EP. I can create a layer now, which I will do. And I will call this ETRV for Edge of Travelway. I hit OK, and I select the option Screen to pick points from the screen, and then simply window all the points in the drawing. It creates a three-dimensional polyline connecting those points. You can view that polyline under 3D View, Drawing Viewer, and select the points. To connect the driveway shots, I'm going to use another method. This time I will use Draw 3D Polyline. Since I had just created a layer called Existing Travelway, I'm going to uncheck the Use Current Drawing Properties and select that layer, ETRV, and hit OK. Then I'm going to type in the range of point numbers, which is point numbers 27 through 44, comma 27, which will join it back to the beginning point 27. Next, I'm going to draw in the utilities that exist in this data set. I do so again by going to Draw Locate Points. I am going to put these points on a layer called Utilities. I'm going to leave the default X as a locator for now. I'm going to draw a point group, which consists of both utility poles and manholes, which is the reason why I'm leaving it a default symbol at this time. I hit OK, and it draws those points. I, however, would like different symbols for the utility poles and the manholes. I'm going to do that through the use of Edit Multiple Point Attributes. I'm going to take the option Selection Set and a description match of UP to start with. When I hit OK, I will window in all the points, and it will find only the three with the description UP. The only thing I would like to change on this is the symbol itself. So I click on the Symbol tab, enable the symbol, and select from the list a utility pole designator, and hit OK. The symbol now for the utility pole is what I want. I'm going to repeat that same process for the manhole. And I'm going to take a symbol from the inlet and manhole category and hit OK. Again, Draw Locate Points, and I'm going to create a layer called Survey. Select the symbol, triangle, draw the point group, hubs. I'm going to go back now and check my point defaults and make sure that my points are back to the default layer of points, the symbol X, OK, and I'm set to draw my spot shots. All the data from my survey is now in the drawing. Let's continue drawing graphics, topography, and finishing up this plan cosmetically. There's an electric line that runs between these utility poles, and an easement that is outside of that electric line 25 feet on each side. We'll begin by setting to the utility layer by just using the drop-down box on the standard toolbar. We'll now use our Point Group Manager, select the utility poles, and draw a 2D line. Next, we'll offset that line 25 feet on either side, but to a different layer. We will use the Offset to Layer command. The offset layer we are going to use is easement. So this will be creating a new layer called easement. The offset amount is 25 feet, and we'll use the option to offset both sides. And we simply pick that polyline. As you can see, this routine closes the polyline, which is very useful in many circumstances, but in this one we would like the ends of this open. We accomplish that from the Draft Ribbon menu, a command named Remove Polyline Segment. And all we have to do is select the two segments we no longer want. To extend these easement lines beyond the property lines where they belong, we will use the command once again, Extend by Distance. We pick the polyline to extend and simply type in 100 feet, and it extends it that far. Repeating that same command again, we extend the 3 lines. This utility line is a solid line currently. I would like to change that into an overhead wire line. To do that, we use the Annotate menu, Line Types, Change Polyline Type. This command exists in the Survey menu, Change Polyline Line Type. There's a library of line types that you can pick from. By hitting the Next button, you will see the next display of polylines. There's a line type, OHP for Overhead Power Line. That's the one I would like to select. By noting the text size scaler, spacing scaler, and gap size, you can control the size of the OHPs, the text that goes on the line, as well as the frequency of the spacing and the gap in between. I would like the spacing scaler to be 3 for spacing once every 3 inches, plotted inches. The symbol size scaler will be 0.08 and a gap size scaler of 1. I select OHP, pick the utility line, and hit Enter. To draw the other side of the street line, I will again use Offset. However, this is a 3-dimensional break line which cannot be offset using a traditional offset command. We'll therefore use the 3D polyline utilities and offset 3D polyline. I will use the interval method. The horizontal offset amount is 24 feet, and the vertical offset amount is 0, meaning one edge of the pavement will be the same elevation as the other edge of the pavement. And then it's just like a typical offset command, and I just pick the side I want to offset. I now have the data I need to create contours, which I can do from the Survey Surface ribbon, or the Surface pull-down, Triangulate and Contour. I will save a tin file and select Existing, which will create a new tin file called Existing. My contour layers are set to be 1-foot contours with a 5-foot highlighted interval on the layers EXCOD Minor and Major. I will have it label the contours a distance along each contour line of 150 feet. Hit OK and window in the data. An error occurs with a crossing break line. To view what that error is, you simply maximize the contour break line button. As you can see, it shows the elevation error just under 1/10 of a foot. If I want to view that, I can zoom in, and I will see that the location of the driveway overlapped the location of the pavement by a small amount. You could simply use the Trim command to trim those lines back, if so desired, and re-execute the triangulate and contour command. To view that surface model, get View, 3D View, Surface File Viewer, select the existing tin. You can see a depiction of the surface for the site. It's possible to exaggerate that to better see the relief from the elevation change. Next, we will return to the Survey menu and annotate the boundary line and add a lot area. To do so, we will use the Annotate drop-down menu. Once again, it's redundant in the ribbons. Look at our annotation defaults. In this dialog box, you can control which layer the angle, distance, and arc information will be on. I then pick angle and distance. I will use bearing over distance for each line. For the curve, I will annotate arc and label the arc. I pick the arc, I'm going to label the arc length, radius, and delta. You can choose whether the labels are going to fall inside or outside the curve. Label the area, area layout. Again, there are defaults to control the layers and the type of labeling. Once the defaults are set, I'm going to use area by closed polyline. Just a single area. Automatically place a label and just pick the closed polyline. A quick report pops up and you hit exit. It prompts to ask for a lot description, and I'm just going to leave it as default lot 1, and the label is placed in the drawing, of which is M text, and I can move to any desired location. To show dimensional offsets from the building to the property lines, in Annotate, there is a survey text annotation. Offset dimension is the command. But prior to that, let's take a look at the survey text defaults. Again, you can control the layer, the text style, and various aspects of how you would like the offset dimensions to look. When the defaults are set, I then go into Survey Text Offset Dimensions, and it automatically picks to the corner of a building and automatically snaps perpendicular to the nearby line. Repeat that command. And you have your offset dimensions. We're now at a point where we can finish cleaning up the plan, freeze some layers, add a title block, north arrow, and a bar scale. Let's start by freezing layers. We really don't need point numbers and elevations and some of these descriptions on the plan. So we'll go back into our layer manager. We know that our default points on our layer are called PNTS, so we can freeze that entire layer. Our descriptions we will leave on. Elevations, point elevations, we will freeze. And point numbers, we will freeze. We also know that our layer called Survey contains our control points, which we are not going to place on this plan. We will leave the trees and the boundary points, which are the iron pipes. When completed, we'll close this out, and our plan now has descriptions, symbols, contour lines, and the geometric data. Now, one of the options that we did not take was to create an exclusion area when we built this surface model. So we now have contour lines running through the building. So to eliminate those, go into the Draft menu and execute a command called Erase by Closed Polyline. I select the house, and I am prompted to select what types of entities we would like to eliminate within that polyline. Note the option to erase either inside or outside the polyline. The contour lines are polylines, so we select those. The label for the contour is text, so we will select that. We want to make sure that we have auto select entities to clipped on. We hit OK, and the contours and text are removed from inside the house. To add a border, we look under the Settings menu, pull down, and there's a title block. We're going to insert a standard title block. Verify the scale as 1 inch equals 20. We have 2 title blocks to select from. It is intended that each user will create their own title block, either by modifying one of the 2 provided or creating their own title block and saving it with the name T-block followed by any desired character such as T-block 3 or 4 or T-block dash and the company name. Once selected, the preview shows up in the lower right corner. Select whether it is a portrait or landscape, the size of the paper, the layer that the block will be inserted on, border width if desired, margins around the paper, and I'm going to have the option screen pick so I can insert this where I like. Now I am going to be inserting this in model space. You can use this command just the same in paper space if you like. I hit OK. I pick a location, and the dialog box showing all the attributes that are contained in the title block appears. To add text to the title block, I highlight each attribute and add the value. When all the information is completed, click OK. To add a north arrow, look under Annotate, draw a north arrow, and you will see a library of supplied north arrows. Specify the layer that the north arrow will be placed and the scale. Similarly, draw a bar scale. You can also add text and other notation using typical CAD commands, such as mtext or standard text.